Okay, so I paused the last video, leaving us here. We did the first couple steps of this problem to find and graph the inverse of this function. And so we are now on the actual find the inverse part. So remember, the original function here is this. F of x equals, or I'll just say y if you want. It's going to say negative x squared plus 4x plus 5. The thing that's weird about this one is that if I finally just invert it, right? So I invert, meaning switch x and y, you're going to end up with x equals negative y squared plus 4y plus 5. As it stands, sorry, I messed that up, 4y plus 5. As it stands right now, it's going to be really, really hard to find y, to evaluate y on its own, to get y by itself. Because what could I do? Well, I guess I could subtract 5 here. Y minus 5 is equal to negative y squared plus 4y. But I'm still kind of stuck here. The way around this is to complete the square. There's kind of no way around it. Or maybe there might be, but let's just kind of talk about why that would be helpful. The reason I want to do that is because if I have a parabola in vertex form, so I'm going to scoot you over here. Again, here's a parabola. Here it is in standard form. Right. In standard form, we have y equals ax squared plus bx plus c. In vertex form, you got this. You have y minus k, and this is how I write it. Some teachers will move the k to the other side, and that's fine. Equals a x minus h squared, or again, h and k, sorry, is the vertex. Is the vertex. Okay. How do you get from one to the other? Well, the way to get from the standard form to the vertex form is to complete the square. Oopsies. If you wanted to go the other way for whatever reason, you would just multiply it out and collect like terms. Not a big deal. I do want to point this out though, because I don't want to make a video right here about how to complete the square. I'll just find one and kind of share it with you. I will point this out though. The a, or the x squared coefficient in the original function, sorry, in standard form, is the exact same a as it is here. And so, if you somehow managed to find the vertex without completing the square, and you have the function also in standard form given to you in standard form, you can just put the pieces into this equation and get the vertex form. Coincidentally, we have actually already done that. Okay, so we know that the vertex for this graph is 2, 9. So coincidentally, we actually have vertex form. So I'm going to start this over, and I'm going to show you why that's helpful. The original function, again, is this. Alternatively, we could write it as y, oops. And yes, if you didn't do this step first, because maybe you didn't remember that the x coordinate of the vertex is just negative b over 2a, because that's one that I don't really remember often. Sometimes I do and sometimes I forget it. But I do always remember how to complete the square. And so if you complete the square correctly, you should get the exact same thing anyway. Okay, but this equation in vertex form will be y minus 9 is equal to negative 1, because that was the a right here. Put it there, negative 1, so it'll be negative 1 times x minus 2 squared. Why does this help? Well, because now when I actually invert it, so let's actually do that now, and I get it like this, there's only one y, at least like that we can see. It's all in one place, and so it's easier to solve for. So let's actually do it now. So let's see, I'm going to divide both sides by negative 1, so I'll end up with 9 minus x is equal to y minus 2 quantity squared. And to get rid of that squared, I'm going to have to take the square root of both sides. I'll get square root of 9 minus x is equal to y minus 2. Last things here, I'll just wrap this up by adding 2 to both sides, and I'll get y, which is actually f inverse of x. Oops, sorry about that. F inverse of x is equal to the square root of 9 minus x plus 2. And that's our equation. And that's the equation of our inverse, excuse me. So we are almost done here. right? The last thing we want to do, let's see, what step are we on? We did step 3 was actually find it. Step 4 is confirm the domain and range. Domain range of f inverse of x. What do I mean by that? Well, check this out. As is, let's check the domain and range of this function. So if f inverse of x is equal to 9 minus x plus 2, what would be the domain? Well, the domain of this would be, well, we need x values that make the inside, whatever's inside the square root, not negative. So I need 9 minus x to be greater than or equal to 0. This is not too bad hard inequality to solve because we can just add x to both sides. And we're going to get 9 is less than or equal, 9 is greater than or equal to x, or you could say x is less than or equal to 9. Probably the way we would want to say it. We can also check the range because we know, well, the square root function is, and by the way, you might notice that I'm not using the domain and range from the original function, and we'll point out why I'm doing this. I'm just looking at it as if it was any other find the domain and range problem. Well, I know that the square root piece, the smallest it could ever be is 0, and the biggest it could ever be is infinity. And so the smallest the entire y value could ever be, the entire output, would be 0 plus 2, or just 2. So I know that the output, or the range, is going to be greater than or equal to 2. Or if I want to use interval notation, we could go, if you want to say interval notation, or to infinity. Likewise, we could say negative infinity to 9, like that. Sorry. We can include 9, but we cannot actually be negative infinity, so make sure that's a parentheses there. Okay. Check this out, though. Is that at no point when I was actually finding the inverse did I care about the domain that we started with. Remember, this function, we want the inverse to be a function, and so we had to take only a piece of the original function, either the green half, which is on the right side, or the left half, which is the blue side. I'm going to pause this here. I'm going to grab this and put this down here. Okay. Let me just do a little bit of rearranging here. I'm going to draw all of this. So again, on the original function, we said, okay, so here's the graph, here's the vertex right here at 2, 9. The blue half is described by this domain and range in blue right here. And the green one described in, well, green, the right half. Take a second here and pause the video, but the red function that I've drawn, or that I've created, the inverse, what is it actually the inverse of? Which piece of the original function? So I'm going to assume that you just paused the video and thought about it, but this domain and range in red, well, actually I might as well just circle the whole thing. This domain range in red is, well, let's see, x less than or equal to 9, so that corresponds to the range y less than or equal to 9, so that matches both of them. But if we look at the range of the inverse, okay, y is greater than or equal to 2, that corresponds to the x greater than or equal to domain right there. So what we actually created, without really thinking about it, we created strictly the inverse of that piece right there. So here's a question. How would I get the inverse of the blue one? Or how would I even know that the red one is not the inverse of the blue one? Well, check this out. If this was going to be the blue inverse, the domain of the original was, again, x less than or equal to 2. And so the range, trying to keep my words careful, the range of the red one should be less than or equal to 2. But mathematically, algebraically, this should work, right? So where did I go wrong? The answer lies in the taking the square root part. Because again, right here, when you take the square root of something, there are actually two answers. You could take the positive square root, which is what we just did to get the green answer, or the inverse of the green function, or you could take the negative square root, because again, for example, when you take the square root of 4, your answer could be 2 or it could be negative 2. And so that's how we're going to want to deal with this. Is when you're taking when you take the square root of something like that, just be aware. Again, you could get two answers, a positive answer and a negative answer. One will give you one piece of the graph. The other one will correspond to the other piece of the graph. So if I want the inverse of the blue one here, I'll just write it down here, I suppose. F inverse of x is going to equal negative the square root of 9 minus x plus 2. And then the domain of this inverse is going to be all the x's less than or equal to 9, as it should be. And then the range should be all the y's that are less than or equal to 2. So hopefully this video kind of cleared that up and helped show you what happens when I take the inverse of a function that does not start off 1-to-1. Okay. Again, what would also be wise to do is to take this graph, restrict its domain, and graph it along with this inverse and just see what happens. Again, if you did it correctly, you know that they should look like reflections of each other across the line y equals x. Okay, so thanks for watching. I hope this helped. And if there's anything that is still unclear, just let me know. Okay, thanks for watching, folks.